Okay, so now we're going to look at reactions with hydroxide ions. Here I have a metal Hexaaqua ion, and the fact that it says 3+ outside tells me that the metal has a 3+ charge. Now, when this reacts with hydroxide, it's going to react with 3 hydroxide ions, and this will create the following. The charge on this compound will be 0, because the metal is 3+, and 3 times hydroxide is -3. So they cancel out. Because it has no charge, that means it will form a solid, an insoluble precipitate. And also we get 3 water molecules. What if we had a 2+ Hexaaqua ion? This time it will react with 2 hydroxide ions, and we'll get a different product. Now we have 4 water molecules and 2 OH minuses. Again, this has an overall charge of 0, so it forms a solid. And we get 2 water molecules released. So have you noticed the pattern? Let's start with the top one. When you have a 3+ Hexaaqua ion, then you're going to need 3 hydroxide ions. So from the 6 water molecules, you have 3 left, and 3 of them have broken down into hydroxide ions. As for the next one, if the charge is 2+, that means we're going to require 2 OH- ions. Again, from the 6 water molecules, 4 are left, and 2 have broken down into hydroxide ions. Let's look at these reactions in a bit more detail. Starting with the 3+ Hexaaqua ion. If I add hydroxide, the hydroxide will act as a base, forcing the Hexaaqua ion to release a proton. So now we have 5 water molecules, 1 of them has broken down into OH, and also a water has been produced from the hydroxide and the H+ that was released from the Hexaaqua ion. If you add another hydroxide, that breaks down another water molecule, going from 5 to 4, and now we have 2 hydroxides, and of course water is produced as well. Notice the overall charge keeps falling down by 1 each time. We started with 3, then we went to 2, and now it's just +1. What would happen if I add another hydroxide? Now we have 3 waters and 3 hydroxides. Since it has no charge, it's going to be insoluble and will form a precipitate. Now most precipitates are basic. That means if I was to add any more hydroxide ions, it will not react with the precipitate. However, since it's basic, that means if I add hydrogen ions, it should react with it and go back up the chain, forming H2O4 OH2. Now we have a charged compound again, so it will redissolve in the solution. Now if you want, you can keep adding acid until it goes all the way to the beginning. However, it doesn't matter which form you have, 3+, 2+, or +1, they're all going to look the same. Going back to the precipitate, MH2O3OH3. Now some precipitates can be both basic and acidic. This means it will react with hydroxide ions because it's acidic, and therefore it will keep on breaking down the water molecules, giving us H2O2OH4. Now if you look at the charge, you have +3 -1 times 4, meaning the overall charge becomes -1, and it will redissolve in solution. Let's do an example. So here I have an aluminium Hexaaqua ion. In this form, it looks like a colorless solution. If I keep adding hydroxide, eventually I'm going to get this. This compound is no longer charged, so it will form a solid, insoluble precipitate. In the case of aluminium, this precipitate will be white. So we saw that adding hydroxide created a precipitate. Now the aluminium precipitate is amphoteric. That means it's both basic and acidic. That means if I add hydroxide, it will react with it, forming the following. We can see that because there's an overall -1 charge, it will redissolve. So adding excess hydroxide causes the precipitate to redissolve. Again, you can keep adding more and more hydroxide until all the water molecules have been hydrolyzed, and finally we have 6 hydroxides remaining. But it's still going to have the same appearance. It will be a colorless solution. What about if I'd added hydrogen ions to the precipitate? This would cause it to redissolve. So adding hydrogen ions causes the precipitate to redissolve into a solution. Hey guys, if that video helped you, support our channel by liking, subscribing, and sharing it with your friends. And more importantly, if you still have questions, drop a post on our forum at examqa.com, where I will personally be there to help answer your questions. Mohammed signing out.